Hi everyone, thanks for coming. It always happens like this. Previous meetup, the other person didn't show up, so it was the only one. Now I'm the first one, no worries. So, I'm from Nexmo, and I'm a SDET at Nexmo, which is a software developer engineering test for the people that don't know the acronym, or QA engineer, if it rings a bell. I work more specifically in the voice API team. And we're going to talk about QAOps, which is a new buzzword, which combines basically DevOps and QA engineering. So, I'm going to start off, talking a bit of Nexmo and what we are, who we are, and what we do. How is the QA team involved with DevOps and team culture as well? And we're going to go through a bit of more technical stuff. Won't have any coding, but it will explain how the CI/CD pipelines work. So, who we are and what we do. Nexmo was founded in 2010, was acquired by Vonage in 2016, and joined what they call the CPaaS family, which is Communication Platform as a Service. So, this allows you to, communicate via the internet using audio or SMS or many other things. Quick view, don't read this, but if you go online, there's a very clear reference on what our communication APIs do, such as two-factor authentication, SMSing via your web page app, or even doing voice calling, creating call centers, and all that stuff. Now, first section, QA team and DevOps and tech culture. So, initially, why we're one of the people that also ended up doing this. When I was searching for the term, I saw that other companies were also bringing up the same term. And it didn't come as a surprise because as a QA engineer, wanting to make sure that you provide great quality for your product, you end up doing some of what they call operation stuff or DevOps stuff. And this is the only way you can ensure all your services are released nicely, successfully, without bugs. And it involves testing, releasing, developing faster, and it also requires transforming, the typical waterfall system or framework to the agile type of structure. This, of course, allows for scaling your company and assuring quality. Again, as I said, the reason that QA and Ops are basically combined. If you can't see this, it's basically all the fundamentals for quality assurance, which is deliver product to customer, delivery, support, initiation, and stuff like that. And then you get the infinity loop by DevOps, which I'm going to expand a bit more later on. If you look at the words, they're very similar, and hence, it was very logical to combine these two. So hence QAOps. List of responsibilities of a QAOps team or QA engineer is obviously tests, many tests, but also furthermore now with this term, you also checking at monitoring, alerting, and this allows you to make sure you got high availability and resiliency before you even go to production, and obviously while you're in production. A bit of on how our team is structured. Obviously, this is a bit of a mutated Spotify model, which is basically what most of the companies are doing nowadays. Our ABC to F teams are squads or microservices, and we do have allocated SDETs per team. But for instance, there's a team also that does not have any hired people as an SDET. They're actually just fully cross-functional, and they share, who's going to write the test. I'll pick up a ticket with a test, and that's how they share it. We do have bi-weekly meetings because we have an SDET guild. So this helps us to sync and exchange knowledge because we are not strict on how we test our microservices. So if a team or the people in the team decide, we're going to use this framework to do our tests, it doesn't mean that every other team must use that same tool. So we're trying to be agile like that. So, but if all of a sudden you want to test something and another team has done it, obviously, exchanging this knowledge will help you to achieve your goal faster. So moving on now to the more technical stuff, if I may say. CI/CD pipelines and the way towards the infinity loop, and as you're going to see further down, the chaos engineering aspects. So, yeah, first of all, I automate. So this is me many years ago doing manual testing. So if you don't have a wind turbine, this is what you do. Your professor drives the car, you sit there on the top, you look at the multimeter and you check, the efficiency of the blades, and you hope you don't crash. So thankfully, you can automate things now. And obviously, the main goal of automation and testing everything is, you want to develop faster, deliver faster, maintain quality, and keep everyone happy. So moving on to the tools that we use specifically for the API testing. These are all the tools we don't use. We're not saying the bad tools, but a quick Google on how to test APIs brings you up some of them are paid, some of them are free. But when Nexmo started, in a startup environment, and you just have one or two people to code, you're going to use a very easy framework to pick up and to write your first test, because it's unusual. We are basically creating a product for developers, where the developers use to create their own products. So it's not like we've got a web app and we've got to test UI flows and stuff like that. Our flows are mostly based on back-end scenarios. So moving to the tests that we do use for API testing, but it's not only for API testing. So this is the total package we would use to do a full QAOps discipline. So from the left, you can see Python. So we chose Python initially as Nexmo started, and it's still this way as part of the main languages we use for testing, because it was very easy to pick up, easy to write, simple scenarios, easy to do assertion against requests, pass JSON files, etc. Moving down, we started using Gatling as well as some other tools to do load testing, because obviously, you want to test, stress test your environment and see where it will fail. SIP-P is a very, I didn't know when I joined Nexmo. It's testing the session initiation protocol, just like you test REST service with HTTP requests. SIP is for testing the session initiation protocol. Moving more to the right, completely to the right, these are all the frameworks that basically give a lot of value to the stuff on the left. Because, there's no point in writing 10,000 tests and, what do? When do you run them? Do you sit in front of your computer and someone shouts, hey, we're deploying, and you click run. So these tools on the right help us, obviously with Jenkins, as we're going to see later on, is a tool that helps you create pipelines and automate and choose your periodicity of when and your moment of execution during your whole software development phase. And going down, Grafana, Prometheus, Kibana are tools that are used in combination to provide nice metrics, monitoring, and alerting. So, as I said before, Jenkins is very important. Some people love it, some people hate it, because the UI hasn't changed for ages, probably more than 10 years. This is a typical QA pipeline flow for the VAPI team, for instance, but it's very similar for other teams. So each column that you see is basically a stage in the pipeline. So it starts off from the very basic, the developer pushes the code to GitHub, the Jenkins plugin with GitHub picks up the commit, initiates the pipeline. It downloads the latest version, builds and runs the unit tests. The unit test the Jacoco code coverage and static code analysis tool runs. Then we have another product called Sonar Scanner. Well, not our product, third-party product that we use, where we define quality gates, which I'm going to speak soon about. And in the middle, we see the two stages, which is creating your testing environment. So it's a very important step, as we're going to see later on. And in the end, we've got the testing, or the more QA stages. So starting off with the software development stage, as I said, developer pushes the code to GitHub. The Jenkins job starts to run, and we go through the building, the static code analysis tools, and then we use Sonar. So SonarQube is a very nice tool that integrates static code analysis tool. It's open source, most of it. You can buy a paid version, which is also on the cloud, so you don't have to host it. It's very nice on how you define quality gates. For instance, if there's a new bug, so as you see here on the left side, as you install SonarQube, it detects the moment of creation of the SonarQube project, and it treats all your code up until now as the old code, and any new commit will be the leak code. So it separates that. So you can start applying your quality gates, because obviously, if you have 50% coverage and you want to apply 80% coverage, you got to do so much refactoring, you'll never be able to release production. Because in the end, these quality gates will be the blocking points where you would not be allowed to release to production. What else? Yes. So the cons for this. It takes a while to get to learn. More importantly, it takes a while to get the developers to learn how to use it. Because, some of them might get a bit frustrated when they see, if they haven't written a unit test and the code coverage is dropping. Some people might argue that they don't need to write a unit test for that, or various reasons. So it takes time to teach the team that this is valuable, and obviously through consensus, they must all agree to use it. Because if only one person wants to use it and he tries to enforce it to others, then it's not going to work. Moving on now to the test environment creation stage. So this is very important because you've got your code, your newly built code, you got your project, you got to deploy it. So NP is what we call the Nexmo playground environment, which is basically spinning up your instance, which resembles production. So the nice thing about this, obviously, is that you choose all the versions that you want to apply. So say, if your production, say, is a cluster with, 20 nodes, and there's 5 different microservices, this in-house tool that we built, that Sufyan built from the DevOps team, we can very nicely, when we hit the API, we choose, this JSON file extends way longer than what it looks, and you can choose what type of instance you want. If you wanted to have 4 cores or 20 cores or 80 cores, you might get a call from finance if you go too high. So you can choose all the versions, as you see. So branches, tag names, and stuff like that. And that will help you, know exactly what you're testing and what version of your pre-production environment is you're testing during the pipeline. Moving now to the last bit, where we actually write all the tests and we've got to make use of them. So, as I said before, there's no point, having 1,000 or 10 million tests and you have to manually trigger them, or you don't have a preset stage where they get triggered, whether that is during software development, continuous integration, deployment, etc. So the last stage I'm going to talk about is how we implement these tests. I'm not going to go into too much detail. As I said before, our main testing suite is Python. It's very easy to do a request. As you can see on the bottom left, you basically just do a post request. You capture the response to variable. You check for the error code, or you check for you pass the JSON that you get back. You can do a lot of things with the Python request library. One of the next steps of the testing stage, which obviously these pipelines are not written in stone. So you, depending on in what stage of your development phase you are, you can choose what to execute. For instance, you don't want to have if you want a fast feedback loop, you don't want to run tests that you're going to take 2 hours to run. Those are going to be nightlies and stuff like that. So one of the other tests disciplines that we do is load testing. So for this we use Gatling because it's very nice, and we chose to. Now we also use Locust, but the nice thing with Gatling is it creates very nice reports and histograms and you get very nice visualization of latency latency between requests and stuff like that. And it basically generates like a proper web page. And you actually open it on Chrome and you go back and forth, and it gives you a very nice understanding of what's going on. Moving on now to a very important bit of the QAOps. And this is basically one of the reasons that QA engineering becomes QAOps. So this is what typical Grafana dashboard looks. You can't clearly see, but for instance, this is one window, this is another window, this is another window, this is another window. These are, again, two windows. And it's extremely customizable. And each team, obviously, fits this to their needs. And ideally, you want TVs all around the office place, displaying stuff, money maybe for finance team, because you can extract that. So if you're capturing, through the API that handles your payments, you can extract that value as well. So, for instance, for the top row is showing traffic, request traffic on different DCs. I think yellow is USA and the green is EU and stuff like that. This allows us to have a very clear view on the physical impact that's happening on our system. So, for instance, if we get an alert, some of the stuff might go red or green, and then you know exactly what's going on. Oh, I had a spike, and you can act. Obviously, you integrate this with a Slack channel, and you can get Slack or Monet or emails and stuff like that. And another dashboard of a Grafana that's very nice, I believe, because this allows you to visualize a lot what's going on with your product. I mean, even I didn't know. I'm like someone here in the middle of the Pacific, is executing requests. And it's so nice to see, even from a product point of view, but an engineering point of view. I mean, it makes you realize as an engineer, the stuff I'm testing and making sure that it's working, I don't know, that could be like a thunderstorm alerting system there. You want to make sure it's up. So it's very nice to get this sort of insight. And in the end, I mean, one of the many, again, as I said, dashboards which you can create is one that obviously shows you the status of your servers. So you have CPU load on the top left, memory on the top right, and depending again on your thresholds that you put and the spikes that you have, you can either make it alerts, notify people, and stuff like that. Moving on to the data pipeline. So Grafana is able to display all of this valuable dashboards due to this part here. So Grafana uses Prometheus in the background as well. And with Elasticsearch plugin, it allows to get all that info and display it as metrics. So all the logs that are generated in production, we use the ELK stack to save them. And these, as I showed you before, are used for our monitoring purposes, Grafana and stuff like that. But this stack is also used by the data science team and the business intelligence team and stuff like that. If you have successfully done all the slides that I told you before, you could eventually end up doing what we call chaos engineering. So what chaos engineering is, I'll give it briefly. I mean, we're aiming to achieve that at Nexmo. We're not there at the moment, but we have started doing our attempts. Once you achieve the CI/CD, you should be testing in production. Like people that say, back in the day, testing in production would be a big no because you don't want to risk dropping your environment. But again, just like Spotify made a trend, the agile model and squads and chapters and all that stuff, Netflix, they made this. Everyone's talking about how Netflix just kills a random server in production and everything's fine. So imagine not being able to watch, I don't know, Game of Thrones or that's HBO, I think, right? So yeah, so basically what it is, essentially it it's what fault injection is. It's what in the old days used to be fault injection, but it's for the cloud. So you forcefully shut down service in production, but obviously before you do that, you have run that through your testing phases, your staging environments and your development environments to make sure that when you do it in production, it's not going to fail. This is the only way you can assure you're going to have the highest possible availability and resilience. This is the logo of the Netflix Chaos Monkey tool, what they call. It's called the Simian Army. So yeah, it runs and it just randomly kills stuff in production. Cool stuff. So once, ideally, if we have in chaos engineering as well, you could achieve this without, though. But after your CI is fulfilled, you end up doing continuous delivery. So the reason they call this an infinity loop is because this never stops. I mean, theoretically, ideally, you shouldn't need approval to deploy something in production. You should be certain enough that, oh, there's a hot fix, boom, release production, no product owner needs to prove it, no manager, nothing. So this loop here is a very nice way to visualize what goes on. So imagine here, like build, merge, code, branch, all this stuff here. It's basically, the first stage of the CI pipeline process, and then release deploy could be, maybe if you're using Kubernetes or Nomad from HashiCorp if you're doing that type of deployment. And all the green letters are basically where you got to make sure that you're testing the right thing at the right time. As I said before, you can't be running like 2-hour tests right before you deploy. You got to have your like basic verification tests, like Spotify calls them, which assures you that production is providing minimum functionality and uptime, and gives you fast feedback because you want to fail fast, so you know if something's wrong and then fix it fast. So as you see, this is a entangled loop, is an infinite loop. So it's wrong to like separate QA from ops. Everything should know about how the continuous delivery or deployment works, and they all should be involved in it. So that's it for me.